Good afternoon, ladies and gentlemen. We are Group F, and I'm Eve, graduated from the University of British Columbia in Vancouver, Canada. Obviously, I come from Canada, and I would like to pass it on to my member, Neither anyways.
Hi everyone, my name is Alex. I'm studying in the National Taiwan University and major in the Biodevelopmental System Department.
Hello everybody, my name is Joyce and I'm studying in National Chengdong University.
Hi, I'm Harris by Eating. I study in National Zhongxin University.
Good afternoon everyone, my name is Stephen Day. I'm from India and I'm doing PhD in National Chengdong University.
Hello everyone, my name is Lian and Hong Lian and I study at National Taipei University of Business and I major in Department of Information Management.
Hello everyone, my name is Anne. I come from Thailand. I'm studying in environmental engineering at Thailand. Yeah, and today we're going to talk about parachute or steel bridge, artificial wetland. We are from Group F and this is all our flag. So this is all outline. We're going to talk about 4 parts. First part is breakdown, solution, marketing, and conclusions. So, water is important, right? So, nowadays, population growth is increasing continuously. So, it's generating 2 problems. First one is we need amount of potable water needed for consumption. So, we have to find out the water supply to satisfy our needs of human, right? Number 2, the more people create the more wastewater, so we have to regenerate it to be reused again. So, Bashu or Steel Bridge Artificial Wetland is located at Bashu District, Kaohsiung, at Taiwan. This here, as can you see, and it is a recreational area consisting of wastewater treatment plants such as oil and grease tap and gravel contact oxidation purification, or GCOP, and then it's wetland. The wastewater is come from many sources such as domestic wastewater and petroleums, and these waters will reject by GCOP in biological processes. And biofilms that cover the gravel is capable for degraded organic substance. So the effluent can be purified, but it still have to be treated again by wetlands for second processes. So the water that come out can be clean and is a better quality, so can release back to the Kaoping River.
With the present condition of the wetland in the Dashu area, Kaohsiung district, is not getting stable water sources like from the nearby household to treat and supply to the wetland. And after 2009 typhoon record, it faced a huge filtration problem. And now what we should think about to relieve a wetland, because the wetland is one of the most cheapest way to retreat wastewater, and it takes less management power, less energy, and moreover it provides a pleasant environment for the visitors.
And it is very important to protect our wetland rights. So we come up with 2 solutions to solve the unstable water and the filtration problem. And we use super tree to stabilize water supply. And look at super tree. There are 3 sorts of super tree. It include the rainfall and have protein flow and moisture. And I want to introduce hyperic flow first. And look at this zone. And water in this zone mixing in shallow warm water and surface water. We call hyperic flow. And why we use hyperic flow? There are 3 reasons. One is hyperic flow is more cleaner, and second is if we manage it properly and will not subside. And the third, because our hyperic flow is slower than the river, so we will have a longer water intake period. And maybe someone will ask, is it properly to use hyperic flow in this area? Okay, we can check the geological structure in this place. And this is dark blue area. And the dark area is almost sand and then gravel at the first aperture. This is a good condition to collect the interflow in this area. And this is the radial well. Like the 2风距 in Pingdong, we also use the radial well to collect the hyperbaric flow. And it's new. Actually, it already have the facility to collect the hyperbaric flow in this area. And this is a park. The children have fun, and they are pumping the hyperbaric flow.
Alright, thank you, Alex. And then, besides rainfall, we also do the moisture harvesting the roof of the super tree, and we also store the water in the tank normally. But then, when we need water there, we can pump it out. That's why we have the pump. And another thing is that when we lack water in the wetland, we supply water from the tank. Next. When we have rainfall, obviously we can collect water on the roof and flow direct it into the tank. Once again, when we have a typhoon, other places may not have clean water, so we can supply our stored water to these places and empty the tank. With our empty tank, we can collect a whole lot of rainwater because we have an empty tank. Next. During the wet season, we will use the interflow first and then the rainfall. But then during the dry season, since we do not have enough interflow, we will mainly be using the water we stored in the tank from the wet season. This is the overall schematic with all the components there. You see the cross section of the radial tube, the radial well here. We have a underground tank. Storing water, and here's the structure of the super tree.
Thanks, Eve. And let's see. We have 3 phases of wetland, and in this picture we can see the super tree is only built in phase 3 because it isn't a protect area. But we should plant the mangrove trees around the wetland, including phase 1, 2, and 3, because it is the most economic and active siltation prevention option for wetland. And mangrove is an aquatic plant that can prevent the eruption and block flood during heavy rainfalls. And then the main function of the mangrove is that firstly, resist tide and flood. Secondly, filter potent and organic matter. And thirdly, provide habitat for creatures. It is not only fit local ecology, but also improve the extra natural habitat for water creatures. And then so we need to balance between dominant species and native species because it is the best way when they are in the same species.
And we need to use different methods at the same time to treat the river erosion. There are engineering method and non-engineering method. Engineering methods include check dams, desilting basin, hydraulic troughs, and ground seal in the top of the river. And non-engineering method includes stacking and watering and vegetating engineering, soil and water conservation, promotional education. As you see, this is many formula. By apply the method, we can increase the roughness of efficiency and decreasing the slope, and then we can reduce the velocity.
Okay, this is my turn to talk about marketing. Marketing, yeah. And first one, I will talk about SWOT, and the second one, I will talk about BE and PTT. SWOT, SWOT is an word to analyze the business cases. And talking about strength, it can combination of business development, ecology, preservation, and engineering solutions. And to talk about weakness, we had unstable water supply and selection. And to talk about opportunity, we have tourism, business profits are not to the public. And to talk about threat, we have objectives for research and visual impact. And the second one, to talk about BEE, it's business development and engineering solutions and ecological preservation. And to talk about PTT, it's perspective with reason and talk with MC and template with benefit. Yeah.
Well, from the short field trip and summer camp like 2 weeks, it's really difficult to give a effective solution, but we believe.
I'm sorry. Okay, so.
I have a question. You want to build maybe several super trees in a river. How to reduce water level? Because the super tree in the river maybe cause the water level higher and higher. Okay.
Is it necessary to clean the underground tank?
For your artificial wetland, the major purpose of artificial wetland is to improve the water quality. And now you are trying to use 2 water sources that those are very clean. So why not use a cheaper way? Just use the water from the Golden River. That's cheaper. You don't need a lot of work to get the water, and also you can increase water quality. Okay. So you have 5 minutes. You have 5 minutes. You can start.
Well, thank you for your questions. Our first question is why we are building super trees in the river. But I want to make a clarification, like we are proposing to build super trees in the wetland. Super trees will receive the rainwater, and rainwater is more fresh, and we connect the pipe to the underground storage and we will store the water. I hope this may answer the first question. Is it okay? We are building the super trees in the wetland, like not in the river. So river is another option. We are taking also water from the river. These are our suggestions. we can choose only one, not both of them together.
Well, thank you for your question, jury members, and I will answer the question too if it's necessary to clean the water tank. Well, since the source of our waters are pretty clean, and to be honest, we don't need to clean the water tank very often because we have the interflow, the interflow is pretty clean already. The rainwater is also pretty clean, and we also have a moisture capture, and that's also pretty clean. And to be honest, I don't see the point of cleaning the water tank. We may have to check it sometimes, but not very often. And I hope this answers your question. Thanks.
Okay, I'm going to answer the third question. And the third question is why we take the water from a Gulping River, right? Because we think the Gulping River water will have the tank, and if the water have the tank input the wetland, they still will have the filtration problem. So we consider to use radial well to pump water and intake. And when we need, we can take water from tank to the wetland. Okay. That's all.
Anyone want to answer more? Just give it time.
应该现在，我们说的是台湾人。